There's one more thing to consider when you're working with the singleton design pattern, and that is the possibility that multi-threading may interfere with your test to see whether or not the singleton object has already been created or not. And that's a definite possibility, a small possibility perhaps, but if you're going to guarantee that you only have one single object using the singleton design pattern, then you should take a look at it. Here's the test that we make, and if the object does not exist, create it with a new operator and the private constructor, as you know, and return that object. And if the object already has been created, simply return the object. The problem is, and this is a slight possibility, but it's a definite one, when you're making the test for if single object is equal to null, two threads might, operating at the same time, might get into this code, and at the same precise moment, the object might not exist. So in fact, two threads operating at the same time might get past this test. The singleton object might be null, and before it gets a chance to be created, the second thread comes in and tests, and the object is still null, and so you execute this line of code twice. That's a definite problem with multi-threading. So one solution is to use, we're going to create a new version called database synchronized in order to defeat that problem. And the only real difference here is that you're going to use the Java synchronized keyword in the declaration of the class's getInstance method. Synchronized means block all access to this code except for one thread at a time. In other words, only let one thread at a time through. So this will fix the problem. You can use synchronized like that. Just putting in the synchronized keyword blocks the access of multiple threads to the code inside the method, only letting in through one thread at a time. That means that if the thread gets through and sees that the single object is null, it will create that object, but the other thread is still waiting and will not be able to get through and make the same test in an interfering fashion. So the synchronized keyword is an important one to know about. And now we can test the singleton. We'll call this new program test singleton synchronized. And we're going to, in this test, we're going to create a database synchronized class. And we're going to create the object called database. We're going to then use the database synchronized static getInstance method to create a database called products, which will store in that database variable. So this is now going to be a database with the name products. At the same time, we're going to use a worker thread and start the worker thread like this. The details aren't really important in Java if you don't know what's going on, but in any case, the idea is that we're going to start a new thread, and this new thread, the code in this new thread will actually try to create a new database using the getInstance method, and that database will be called employees. And so the thread will print out, this is the database.getName database. And so if you see this is the employees database, you have a problem, because the main thread of the program is going to print out, this is the products database. And if you see this is the employees database from the second thread, you have a problem, because then you have created two different objects. You're only supposed to be creating one. So let's give this a shot. And here you have, we're going to test the test singleton synchronized program. And in fact, you see this is the products database twice. So in fact, what's happened is that even though the thread tried to create the worker thread tried to create a new database called employees, it was not created, and what was returned from the getInstance method was, as it should be, the products database. So that's one solution for working with the singleton design pattern. If you're worried about multi-threading, you just use the synchronized keyword in the getInstance method. That will prevent all but one thread to get into the getInstance method, and so only one thread at a time will execute your code, the getInstance method, and multiple threads will not be able to defeat this test, see whether or not the single object is null or not. So that's in case you want to be very careful about what you're doing with the singleton design pattern. Give it a shot, use the synchronized keyword, and you should be fine.